Hey guys, what's going on? So today I want to walk through a fun little project that's going to not only test your ability to do some basic Python scripting, but at the same time, test your ability to solve mathematical sequences. Coming right up. Alright, so what I did is I built a simple script. Let's run through the game first, and then after that we'll go ahead and walk through the code. And this is one of those scenarios where I made the code very basic. I purposely try to keep it simple so that you can understand the logic, and then you can go back and optimize the code later on. But anyways, let's go ahead and play this. So the way this works is you're going to get a sequence that you got to go ahead and fill. And every time you get this mathematical sequence, the sequence, although the algorithm is going to be the same, the sequence itself may change. It may have a different starting position. It may have a different ending position because that's the way we've coded it. So if I go ahead and solve this one, and I put in 34 because I know that's the right answer, what it's going to do is it's going to say you got it right, try the next one. And it gets harder and harder as we move forward. Now I cheated and I actually printed the answer here because I didn't want to solve this while I was demoing this. But you can go ahead and put anything you want here. So I'm going to put the wrong answer. I'm going to put 500. And what it's going to do is it's going to say you got 1 out of 3 because I've defined 3 different math sequences in here, and it's going to say go ahead and start over. So let's do that. So you notice that the answer for the second one was 505. It'll probably change in the next run because it's randomly picking the sequence itself. All right, so let's go ahead and rerun this code. Now we're getting a slightly different sequence, so the answer for this one is going to be 21. Remember, the second one we had 505, so it's changed a bit. Now it's gone down to 175. So I'm going to go ahead and put in the right answer, 175. And then once I do that, it's going to give me my last one. And the answer to my last one here is 150. Again, I've cheated. So I'll go ahead and put in 150. And when you do that, it's going to say you got them all right. Congrats. Now, if I went and put the wrong answer in the second one. All right, so now let's go ahead and do this again. This answer is 34. This is 369, which we'll put in, and then we'll put in the wrong answer here. We'll say 200, and now it's going to say you got 2 out of the 3 of them right. So you can go ahead and add as many different math sequences as you want. You can play around with the algorithms. You can do whatever you want in that case, but it's a fun little game because the answer does change every time based on the sequence that comes. Once you figure out the algorithm, obviously it is not that difficult to solve. But this is just an introduction to a little bit of fun with Python. So now let's go ahead and review the code. So I have the code open here in Sublime Text. And what you'll notice is I'm going to use different IDEs just because I get requests, people saying, hey, what's better, PyCharm? Is it Jupyter? Is it Sublime? Is it VS Code? So what I'm going to do is I'm going to walk through all of them at some point, and we can go ahead and just tinker around with different ones. So for those of you who figured it out, the first one was actually the Fibonacci sequence. It's a very popular mathematical sequence. And although I've defined each one of these different algorithms within a function, the methodology is actually the exact same. So once I walk through one of them, you can go ahead and pretty much walk through the rest. And the reason why I said this isn't fully Pythonic is there's a bit of duplication here. So, some of these lines here are duplicated because the only thing that's really changing is the algorithm. So we can always wrap this in a larger function and, just have less repetitiveness. But I figured for the sake of actually just demoing this game, this would be an easy way to do it. So for those of you who know the Fibonacci sequence, the algorithm is quite simple, and that is, if I have a sequence, so let's go ahead and just write something down here. I'm just gonna write it in comments. So the Fibonacci sequence goes as follows. It starts with 0, 1, and then the next number in the sequence is always going to be the previous number plus the number before that. So in this case, 1 plus 0 is 1. And so the next number is going to be 1 plus 1, which is 2. And the next number is going to be 1 plus 2, which is 3. And then 5, and so forth. So that's how the Fibonacci sequence works. It's actually a very popular mathematical sequence used in various different areas. They actually use Fibonacci sequence in gambling. They also use it in agile methodologies, which you can read upon. And so because the Fibonacci sequence always starts with 0 and 1, I've gone ahead and defined these two. And what I've said is, for the next item in this list, so we're going to start the list at element number 1. So basically, when I is equal to 1, this is going to be the second element, because we've already defined 0 and 1, so we need the second element. It's going to be equal to the element, which is sequence 1, so that's 1 in this case, plus I minus 0, which is sequence 0, which is why you need to define these up front, otherwise it'll give you an error. And that's the one difference with the Fibonacci sequence versus the other algorithms that we're going to walk through. Finally, you're going to create a dictionary out of that. And as you create the dictionary, you're going to iterate all the way up to a certain point. And I said the max range that I want to define here is just give me a number between 8 and 10. So it's either going to go from 1 to 8 or 1 to 10, and that's because I want it to throw off the variability of the algorithm itself. So when the sequence prints, I don't want it to be the same sequence every single time. Finally, we're going to pop the last letter, and we're going to store that as num. And for those of you who remember, when you pop a list, it takes the last element off. If you are a little fuzzy on pop, I'm going to link my Python for Beginners tutorial above, and you can go ahead and learn that in there. Finally, when I go ahead and print my sequence, I also want to change that up. I want to start from either element 3 or element 4, and you can tinker with these numbers. You can put 2, 4, 1, 4, whatever you want there. And then you're going to go and ask the person to guess the number. And as you guess that number, you want to make sure that when they're inputting that number here, you're going to convert that into an integer. That's very, very important. If you don't do that, it's not going to work because it's going to try to compare a string to the actual number here, which is an integer itself. If you do get it right, you got it right. Try the next one, and then you go ahead and call the magic square function, which is basically this line of code, exactly as above, but we'll get to that in a second. You're going to call the magic square function. If you don't get it wrong, you're going to say incorrect, start over. And when you go ahead and call the magic square function, it's basically going to call everything in here. Everything here is the exact same as above, with the exception of the actual algorithm itself, which is going to change because this is the magic square algorithm. For you guys who are not familiar with it, you can go ahead and read upon it, but this is essentially the way it works. And then once you get that, you're going to go to the most complicated one, and that's the one I just randomly defined. I just came up with a random algorithm here and did that. And if you guys want, you can go to the nth degree. You can define another one. You can say complex 2 down here, and then just after you guys get this one right, you can go ahead and put it right here after this line. Now, remember, I went and printed those numbers because I cheated. I didn't want to solve it, as we were going through it. So you can always go ahead and just comment that out. And we'll comment this one out too because we don't want the numbers or the answers to print, obviously. And once you do that and you go ahead and save this, you rerun it. And you're going to start it off with the Fibonacci function because all the other functions thereafter are already embedded within that. So you're going to start it off with the Fibonacci sequence. And if you get this one right, it's going to go ahead and move over to the magic square function. If you don't, you start over. And we just defined this, very simply here to say that if you did get it wrong, you did get 1 out of 3 because in order to get to the magic square one, you had to have solved the Fibonacci one, obviously. And then if you got this one wrong here, you got 2 out of 3. So these are hard-coded in. You can always go ahead and put an algorithm or put some coding in there to make sure that that is also dynamic as well and changes. So this was just a small little tutorial, a fun little game that I thought for some of the beginners out there, the newbies who wanted to understand how some of these things work, you can go ahead and create something like this. It's a great first project for some of you people out there. And then once you have that, you can go ahead and define your own algorithms in here. You can put whatever you want and see if it works. And if it does, then great. If you do actually expand upon this and you add in more algorithms, link it in the description. I want to go ahead and see what you guys have done. But again, this was a quick little tutorial, a little fun game. If you'd like this, comment, subscribe, and I will talk to you next time. Thanks very much, guys. Bye.